Hello everyone. Today we will be discussing chemical reactions. Specifically, we will be focusing in on the combustion reaction of propane. To begin, a combustion reaction is a rapid reaction of a substance, often hydrocarbons, with oxygen whose products are often carbon dioxide and water. Next, I would like to go over what a chemical reaction is. A chemical reaction is a change in which new substances are created from starting materials. So in this case, the starting materials, or also known as the reactants, would be propane and oxygen. A property of propane would be that it is a colorless, odorless, non-toxic gas. Additionally, a property of oxygen would be that it is a colorless and odorless gas as well. Also, this reaction has a chemical equation which describes what happens when a chemical reaction occurs. So the chemical equation for this reaction would be C3H8 plus O2 reacts to produce CO2 plus H2O. Now we will break down what this equation represents. The compounds on the left represent the reactants, which are the starting materials in a chemical reaction. Then the arrow means reacts to produce. Finally, the compounds on the right side of the arrow represent the products. The products are chemical substances produced from the chemical equation. So, the compounds produced through this chemical equation are carbon dioxide and water. A property of carbon dioxide would be that it is a colorless and odorless gas. Then for water, it would be a clear, colorless, odorless liquid. We can also classify the chemical equation as exothermic or endothermic. An exothermic reaction is when the total bond energies of the products are less than the total bond energies of the reactants. However, an endothermic reaction is when the total bond energies of the products are greater than the total bond energies of the reactants. So with that being said, this reaction would be an exothermic reaction because the products have less energy than the reactants. Or to put it into simpler terms, heat is released from the reactants and that results in the products having less energy. This chemical reaction has many uses, such as being used to cook food on grills, fuel vehicles, clothes drying, backup power, etc. Also, this reaction does not occur in living organisms like humans. Now we will discuss the equation. Currently, the equation is unbalanced, which means the number of elements on the left side is not equal to the amount of elements on the right side. Now we must balance it. But first, I would like to review before we complete the math. A balanced equation is when the number of elements on the left side are equal to the amount of elements on the right side. It is important to balance the equation because if you left it unbalanced, then it would not follow the law of conservation of mass. The law states that mass cannot be created or destroyed. So when an equation is unbalanced, mass would be created and destroyed. By adding coefficients, you can balance out the amount of elements and follow the law. So to balance it, we would first draw a line down the middle where the arrow is. Now we will list out all of the elements that are on the left side of the arrow. In this case, the elements would be carbon, hydrogen, and oxygen. So we'd write down all of the elements and rewrite them in the same order on the right side. Now we will count out how many elements there are on the left side. Since carbon has a subscript of 3, that is the amount of that element. Also, hydrogen has a subscript of 8, which means that is the amount of hydrogen. And finally, oxygen has a subscript of 2, so 2 would be the amount of oxygen. Now we will move on to the right side of the equation and repeat the process. 2 would be the number for hydrogen, and 1 would be the number of carbon. In this case, oxygen appears in 2 spots. Then, in this case, we would add them together. Since the first oxygen has a subscript of 2, and the second one has no subscript, the total would be 3. As you can see, the numbers are not equal. So to make them balance, we need to add coefficients in order to balance them. To balance it, first we would add a coefficient of 3 in front of CO2. When you add a coefficient to the front of a compound, the coefficient gets multiplied by the subscript. Now, the amount of carbons would be 3, and the amount of oxygen would be 7 because 2 times 3 is 6, but we can't forget about the second oxygen. Next, we will add a coefficient of 4 in front of H2O in order to make the hydrogens equal. Now, on the right side, there are 3 carbons, 8 hydrogens, and 10 oxygens. Now the only thing that is unbalanced is the oxygen. So to balance them, we would add a 5 in front of the O2 on the left side. Since 5 times 2 equals 10, it equals the right side, and now the equation is balanced. Finally, we will be solving an equation involving limiting reactants. A limiting reactant is very important because it determines how much product will be formed. So for this problem, there are 7 moles of propane and 11 moles of oxygen. Now we will create a table in order to find out the limiting reactant. The top left corner will be the given, which is 7 moles of propane. In the top middle, we will write the amount of oxygen given in the original equation, which is 5. And on the bottom, we will write the original amount for propane, which is 1. And next, we're going to multiply the two top numbers. So 7 times 5 equals 35. Then we would divide it by the bottom number, which is 1. And in the end, we get 35 moles of oxygen. And going back to the original numbers, we have 11 moles of oxygen, but we need 35 moles of oxygen. In this case, we do not have enough of that reactant, so the limiting reactant is oxygen. That concludes this video. Thank you for watching.